Have you ever looked up at the night sky? Have you wondered about those twinkling lights? You are looking at a tiny part of a vast space. This space is our cosmic home, the solar system. It is a place of incredible wonder and immense scale. Our solar system is not just empty space with a few objects. It is a dynamic and interconnected system. Many different celestial bodies move within it. They all follow complex yet understandable rules. Understanding this system helps us understand our own place in the universe. It is a journey of discovery that humanity has been on for centuries. At the very heart of our solar system is a star. This star is our sun. The sun is incredibly important. It provides the light that allows us to see. It gives us the warmth that makes life on Earth possible. Without the sun, our planet would be a dark, frozen wasteland. The sun is truly massive. It contains more than 99.8% of all the mass in the entire solar system. Imagine that. It is a gigantic ball of incredibly hot gas. This gas is mostly hydrogen and helium, undergoing constant nuclear reactions to produce energy. This energy travels through space to reach us here on Earth. So, what holds this entire system together? The answer is a fundamental force of nature. This force is called gravity. Gravity is an invisible pull. It exists between any two objects that have mass. The more massive an object is, the stronger its gravitational pull. Sir Isaac Newton was one of the first scientists to describe gravity mathematically. He helped us understand how it works not just on Earth, but throughout the cosmos. Gravity shapes galaxies, stars, and planets. It dictates how they move and interact with each other. It is the silent organizer of the universe. The sun's gravity is the most powerful gravitational force in our solar system. Because the sun is so massive, its gravitational pull is enormous. This powerful gravity reaches out across billions of kilometers. It firmly grips all the planets from Mercury to Neptune. It keeps them in their specific paths as they travel around the sun. The sun's gravity also holds on to moons, asteroids, comets, and even tiny dust particles. Without the sun's strong gravitational embrace, all these objects would simply drift away. They would be lost in the cold, dark emptiness of interstellar space. Gravity is the cosmic glue. Our solar system is home to 8 major planets. These planets orbit the sun in a specific order. Starting closest to the sun, we have Mercury. Then comes Venus, our nearest planetary neighbor. Next is our home, Earth. After Earth, we find Mars, the red planet. These first 4 are the inner rocky planets. Beyond Mars lies a vast asteroid belt. Then come the giants. Jupiter, the largest planet in our solar system. Saturn follows, famous for its stunning rings. Uranus, the ice giant, spins on its side. Finally, there is Neptune, the distant blue ice giant. These are the magnificent 8. These planets do not simply wander aimlessly through space. Each one follows a defined path around the sun. This path is called an orbit. Orbits are not perfect circles. Instead, they are slightly stretched circles known as ellipses. This was a crucial discovery made by the astronomer Johannes Kepler centuries ago. He formulated laws that describe planetary motion with remarkable accuracy. The sun isn't exactly at the center of these elliptical orbits. It sits at one of the 2 focal points of the ellipse. This means a planet's distance from the sun changes slightly as it orbits. This elegant cosmic dance has been ongoing for billions of years. The planets can be broadly divided into 2 main groups. The first group includes the inner planets, Mercury, Venus, Earth, and Mars. These are often called terrestrial planets. This is because they have solid rocky surfaces much like our own Earth. They are relatively small and dense. The second group consists of the outer planets, Jupiter, Saturn, Uranus, and Neptune. These are known as gas giants or, in the case of Uranus and Neptune, ice giants. They are much larger than the terrestrial planets. They are composed mainly of gases like hydrogen and helium, or ices like water, ammonia, and methane. They lack solid surfaces. Each planet moves around the sun at its own unique pace. This is because of its distance from the sun and the sun's gravitational pull. Planets that are closer to the sun, like Mercury, feel a stronger gravitational tug. Therefore, they must travel much faster to maintain their orbits. Mercury zips around the sun in just 88 Earth days. That's a very short year. In contrast, planets farther away, like Neptune, move much more slowly. Neptune takes about 165 Earth years to complete a single orbit around the sun. This incredible variation in orbital periods showcases the precise balance of gravity and motion. Beyond the 8 major planets, our solar system is teeming with other fascinating objects. Many planets are not alone in their journey, they are accompanied by moons. Moons are natural satellites that orbit a planet. Our Earth has one familiar moon which influences our tides and illuminates our nights. However, some planets have a multitude of moons. Jupiter and Saturn, for example, each have dozens of known moons. These moons vary greatly in size, shape, and composition. Some are geologically active, with volcanoes or subsurface oceans. Others are cold, cratered worlds. Each moon is held in orbit by its parent planet's gravity. Floating mostly between the orbits of Mars and Jupiter is a vast collection of rocky objects. These are known as asteroids. This region is called the asteroid belt. Asteroids are like cosmic rubble. They are leftover pieces from the early days of the solar system's formation, about 4.6 billion years ago. They never quite managed to come together to form a full-fledged planet. Asteroids range in size. Some are as small as pebbles, others like Ceres are hundreds of kilometers in diameter. Occasionally their orbits can be disturbed, sending them on paths that might cross Earth's orbit, though major impacts are rare. Then there are the comets, often described as dirty snowballs. These celestial wanderers are composed of ice, dust, and frozen gases. Most comets originate from the frigid outer reaches of the solar system. They come from regions like the Kuiper belt, beyond Neptune, or the even more distant Oort cloud. When a comet's orbit brings it close to the sun's heat causes the ices to vaporize. This process releases gas and dust, forming a glowing cloud called a coma. The solar wind then pushes this material away, creating the comet's characteristic long, bright tails that can stretch for millions of kilometers. The solar system also includes a category of objects known as dwarf planets. Pluto is perhaps the most famous member of this group. For many years, Pluto was considered the 9th planet. However, as we discovered more objects similar to Pluto in the outer solar system, its classification was re-evaluated. Other dwarf planets include Eris, Haumea, Makemake, and Ceres, which is also the largest asteroid. To be a dwarf planet, an object must orbit the Sun. It must be massive enough for its own gravity to shape it into a nearly round form. However, unlike a full planet, it has not cleared its orbital neighborhood of other debris. The workings of our solar system have a profound impact on Earth and our daily lives. The Sun, our star, is the ultimate source of nearly all energy on Earth. It drives our climate systems and weather patterns. The predictable cycle of day and night is a direct result of Earth spinning on its axis. Our planet is also tilted on its axis as it orbits the Sun. This tilt is what gives us the different seasons throughout the year. Even our moon plays a role, its gravitational pull creating the ocean tides. Earth's position in the habitable zone around the Sun allows water to exist as a liquid, a key ingredient for life as we know it. Our solar system is ancient. Scientific evidence, gathered from studying meteorites, moon rocks, and the oldest rocks on Earth, tells us its age. The solar system formed approximately 4.6 billion years ago. It began as a vast, swirling cloud of gas and dust known as a solar nebula. Gravity caused this nebula to collapse. Most of the material gathered at the center, igniting to form the Sun. The remaining dust and gas flattened into a disk. Within this disk, particles began to stick together, gradually forming planetesimals and eventually the planets, moons, and other bodies we see today. It's a story of cosmic construction over immense timescales. Despite all we have learned, the solar system still holds many mysteries. We are constantly exploring and making new discoveries. Scientists are eager to find out if there is, or ever was, life on other planets or moons like Mars or Jupiter's moon Europa. We wonder about the precise composition of distant worlds. We seek to understand phenomena like dark matter and dark energy, which seem to make up most of the universe but remain invisible. The search for answers fuels our curiosity. Spacecraft, telescopes, and robotic explorers are our tools in this grand quest for knowledge, pushing the boundaries of what we know. Ultimately, understanding the solar system helps us understand ourselves. We are not separate from the universe. We are an integral part of it. Every atom in our bodies, except for some of the hydrogen, was forged in the hearts of stars long ago. These stars then exploded, scattering these elements across space. These elements eventually became part of new stars, planets, and even us. When you look up at the cosmos, you are looking at your origins. We are stardust, animated by the laws of physics, living on a small blue planet in a vast and wondrous solar system. Our journey to comprehend it is a journey to comprehend our own existence.